Hi everyone, in this video we are going to discuss scientific notation. Now scientific notation is really just an easy way for one chemist or a scientist to communicate with another scientist in terms of numbers. So it's an easy way to communicate important information, important numbers. Now, a number like 10 or 100 or 5 or something that's relatively small, we would just voice that number in like you normally would in any colloquial conversation. However, when we're looking at numbers that are really, really big, so on the order of scale of like maybe a million, a billion, a trillion, we definitely use scientific notation. On the opposite end of that, when we have numbers that are really, really small, so maybe 10 points past the decimal, we are definitely going to use scientific notation because it would be a lot easier than saying 0.000000432, whatever it is. So scientific notation is just something that has two different sections to it, and there's very important rules that you have to follow. So the first example I'm going to use is 1.0 times 10 to the fourth. The second one I want to use is 1.0 times 10 to the negative fourth. Now, like I said, there's two different sections. So this first part right here is called the mantissa. So the rule for this section is you are only allowed to have one number in front of the decimal. Okay, that's super, super important. You can never have like 10.2 times whatever. It has to be 1 point something or 5 point something, but you cannot have two numbers right there. The other rule I want to point out, or the other section I should say, is called the multiplier. So this part right here, the times 10 raised to some kind of exponent, that is called your multiplier. So what the multiplier does is it basically allows for you to write the mantissa with one decimal, but then you use this multiplier, basically a chemical formula right here, or a mathematical equation I should say. You use this multiplier to get your number back to the original state. So your multiplier is used to convert to original state. So the best way to go through scientific notation is really just to do some examples because I think it's just easier to learn that way. So the first thing I want to do is look at the two we gave out here first. So 1.0 times 10 to the fourth. Now the most important thing you need to do or learn to do is look at that number. If it is a positive number, so for this example it's positive 4, you should know immediately in your head that this is a large number or a big number. However, if we have 1.0 times 10 to the negative 4, we see that that exponent is negative, we should be thinking, okay, this is really a small number. But right away, you need to get that classification down in order to kind of go through the motion and actually understand how to convert a regular number to scientific notation and backwards. So let's convert these to real numbers. Let's translate. So 1.0 times 10 to the fourth. That means that we need to move the decimal place 4 places essentially. Now this is a positive number, so it's big, so we need to be moving into the right direction here. So we're going to move it 4 places. So 1, 2, 3, and 4. Stop and write your little decimal out. Now any of these little loops or humps or whatever you want to call them, you're just going to fill a 0 into that place. So this scientific notation is actually equal to 10,000. So 1 times 10 to the fourth is just a very simple or maybe more scientific way to report the number 10,000 by indicating that really the only significant number is this 1 in the beginning. The rest are just to fill place, right? To make it such a large number. Now let's look at our other example. 1.0 times 10 to the negative fourth. So now we said that's a negative exponent, so that means we're talking about a really small number. So this time we write 1.0, but instead of going to the right, moving the decimal to the right, we're actually going to move the decimal to the left. So we're going 4. 1, 2, 3, and 4. You stop here and write a big decimal, fill all these little humps in with zeros, and then you can essentially translate this number. So we have 0.00010. You can't drop this 0 here. It's still there. It's given to us, so we just write it out. So this 1 times 10 to the negative fourth is just an easier way of saying 1/10,000th, right? Because 1/10,000th isn't something that's easy to communicate, but 1 times 10 to the negative 4 is actually really easy. So now what I want to do is go through a couple examples together and see if this makes sense. So the first one I want to give you is 4, 3, 2, 2, 6. And I would like you to convert that to scientific notation. So take a second and try and see what you can come up with. All right, did we get an answer? So hopefully you did, but just in case you didn't, let's go through this. So if we're trying to communicate or convert this to a scientific notation, what we need to do is just move that decimal over so there's only one number in front of the decimal. So here's our original decimal right here, and so now we just have to count how many places to go to figure out what our exponent is. So we're here, we go 1, 2, 3, and 4. We stop right here because we just have to have the one number in front of the decimal. So this then becomes 4.3226. You have to use all these numbers. You can't drop them. If we give you a real number other than 0, you have to keep writing them out. So you can't just round it to 4.3 or 4.32. You must write out all these numbers. So 4.3226 times 10, and then we moved the decimal 4 places. So it was the 1, 2, 3, and 4. Since we moved 4, this exponent is 4. Okay, so that's the first one. Nice job. Hopefully you got it. All right, let's try another example. So for this one, I'm going to write out this number, 0. And now 7 zeros. So 1, 2, 3, 4, 5, 6, 7. Now we want to add these other numbers, 4, 2, 2. Please translate that or convert it to scientific notation. All right, did we get an answer? Hopefully you did. Let's go through it just in case. All right, so remember, we can have one number past the decimal. So here's our first number right there. So we have to move the decimal right there, so between the 4 and the 2. So we're just going to start here and count zeros. So 1, 2, 3, 4, 5, 6, 7, and 8. We stop right there at 8. So this becomes 4.22 times 10. Now remember, this is a really, really small number. Since it's small, our exponent has to be negative. So this was then -8. We moved over 8 spots, so this becomes -8. So the correct answer is 4.22 times -8. Good. So hopefully that makes sense. Another thing I want to point out is this is another form of shorthand notation. Sometimes I actually write the dot most of the time, but sometimes you're going to see me write 4.22 times 10 to the -8 or 4.22 dot times 10 to the -8. It means the exact same thing. It's just a different form of notation, but you need to be comfortable with both. All right, so now you must be able to take scientific notation and actually convert it backwards. So we need to be able to go all directions. But now let me kind of throw you a curveball here. 50 ppm. We talked about 50 ppm because that is the concentration of carbon monoxide when you are smoking in a closed situation. So like in a closed room in a house or maybe in a bar or a restaurant or something of that sort. You can actually increase the concentration of carbon monoxide all the way up to 50 ppm. So what I would like you to do is to translate that both into scientific notation. So I want a version like this. And then I also want you to give me a very standard number like this. So please translate 50 ppm into both forms of notation. All right, were you able to do this? Hopefully. It was a little tricky, so if you got stuck, don't worry about it, but let's walk through it together. So 50 ppm, parts per million. So right away what you need to do is create a fraction. So you have 50 all over, we said parts per million, so we're going to divide it by a million. 1, 2, 3, 1, 2, 3. So if you were to type this into your calculator, it would actually spit back scientific notation for you. So it would tell you 5 probably to the -5. So you would translate that to 5 times 10 to the -5. That's your scientific notation for 50 ppm. So there's the scientific notation. Now, I also want you to be able to teach this or translate this into just a regular old standard number, like what you would do to report it without using scientific notation. So if we have 5 times 10 to the -5, that means we have a 5 right here. Here's our decimal. Now it's negative, so we need to go small, so we're going to go to the left side. So we're going to move this 5 places. So 1, 2, 3, 4, and 5. Make your decimal, fill in your zeros, and then I always rewrite it because that looks hideous. And so your real number is 0.0000405. That is actually your concentration of carbon monoxide. It's teeny, teeny, tiny. But for me to say 0.00005 or whatever it is, that's much more difficult, and there's a good chance that whoever is writing it down or whatever might actually mess that number up when transcribing it. So what we do as chemists is we describe things in terms of concentration, so 50 ppm, or I would have said it as 5 times 10 to the -5 in scientific notation. So hopefully this makes sense. If not, please take a second and practice this. This is very important because we're going to move forward to significant figures, and if you don't have scientific notation down, it's actually quite challenging. So please take a second and practice this. Take care of yourself. Have a good day.